Hello everyone, and welcome back to the Houdini Academy Foundation module. In this video, we are going to cover how to start working with instances in Unreal. Mainly, how we can bring some of the vent objects that we have in our meshes folder over here and instantiate them onto our building using Houdini's instancing system. The main reason that in Unreal you want to use instances is because they are very fast and lightweight. It's not just that we are simply copying static meshes onto our roof, which we will be able to do with this tool if we use the split instances mode down here. But the split instances mode basically generates meshes for every single object. We can actually select them right now as individual components of our building and move them around. However, if you have a very large amount of copies of these meshes, this is very heavy. So if we use a standard instancer, on the other hand, then you can see how we now have an instanced static mesh component over here. And these basically combine every single mesh that is unique into one static mesh instancer. And this will allow us to optimize how these meshes are loaded, because only one mesh in this case is loaded. So every single mesh here on the building, that is a small vent for example, is basically a copy of a single mesh in memory. And that's a lot more efficient and a lot faster for Unreal to deal with. Now you might see that there are a couple of changes to the tool since we last finished the last video. And that's simply because I've upgraded the toolset a little bit to support a couple of extra features that I want to cover because I think they're very interesting. First, in this video, we are going to cover Unreal instances and Unreal split instances. And these basically allow us to take these meshes from our meshes folder and instantiate them onto our building, like I mentioned. But then in the next videos, we are also going to cover the basics of creating meshes from FBX files and then copying them with full textures and full collision. And you can see that right now, it looks like nothing has changed. But at this point, this building is no longer placing these meshes. Instead, it is taking the FBX files from my hard drive and it is simply recreating them on the mesh, complete with materials, which I can show you if I disable the materials, and also various types of collision meshes as well. And these will still work. I can still go ahead and play, and I will be able to collide and jump on these objects. And there are various types of collisions that we will cover in these videos. And you can also see that there are a couple of extra visualizers involved, and we will cover this in the upcoming videos as well. But for now, let's have a quick look at what these instances can actually do. So let's switch the tool back to its basic instancing mode. And the first thing you'll notice is that we have these dots all over our roof. Now these dots indicate where instances can and cannot spawn. And I've visualized this using the visualizer so that we can see that we have the vents that are spawning, but then we also have the red dots, which indicate that in this case, the small vents are unable to spawn in these locations. And this is mainly because of our vent spacing, but also because of the size of these vents. And this is done in order to prevent the vents from actually blocking the player, so that the player will always be able to navigate the roof. If I go ahead and click play, and I try to walk between my vents, then in most cases you'll be able to see that the player can actually navigate between the vents, the edge of the building, and also the rooftop elements such as the staircase and the elevators. Now we can control these objects over here. For example, if I change the amount of vents to say 25, then it will now populate every single spawn point. We also have control over how many large vents and small vents we actually want. So if I set this to 0, I will prioritize large vents over small vents exclusively. So we will only have those. On the other hand, if I set it to 1, then we will only have small vents on the roof. And if you change the value to anything in between, you will get a mixture between either small vents or large vents. We also have a seed value, so we can change the actual layout and rotation of these objects, and they will rotate in 4 different orientations. And finally, if we change our vent spacing to something smaller, which will prevent the player from actually passing between them. But you can see that now we can actually place a lot more objects on the roof. And if I populate the entire roof with objects by, say, increasing the vent count to 100, then you can see that we can populate the roof. But they will, in general, as long as you don't place them too close to one another, prevent themselves from intersecting with one another. Of course, at this point, it's going to be very hard to navigate our roof, and I don't think any building ever will need this many ventilation objects, but, well, that's beside the point. Okay, so let's return this back to some of our default settings. So let's go over to Houdini and let's have a look at the new example file, version 1.1. So you can see that I have made a couple of changes in between this video and the last. Down here I have split up the FBX loading system and I've basically put it in its own output. So we have a dedicated output for the meshes that we can generate for the roof. We'll cover this in the next video. And then over here, this is what we'll be building today. This section right here. So the first part we'll be working on is the pillars inside of our building. Let me just hide everything else. And you can see that we do have pillars inside the building, but they are going to make sure to avoid the obstacles inside our structure, such as the elevators and the staircase shafts. And to make sure that they don't get too close to these objects, we are going to use the delete by distance node once again. Next, over here, we're going to cover a couple of different methods on how to build a spawning grid for our points. This will allow us to create points inside of our structure, and then we are going to cull those out, so we only keep a series of valid spawn points. Now we do need to make sure that we can also establish a ratio between our large vents and our small vents, so that's what this section here is going to deal with. Down below we have the instance data assignment. This is a hard-coded database because I only have 2 meshes to instance here. If you want to build a more advanced database, you would basically replace this with a more dynamic system that would load it from, for example, an external file. But right now we don't need that, so we are going to set up a basic setup using a wrangle node that will assign a couple of variables to our points, a couple of attributes that we'll need for our instancing to work. Then we are going to copy these points onto our spawn points so we can assign them. And then finally, down here, we are going to send this out to a dedicated instancer on the outside of our geometry, right there, which Unreal will pick up, and then it will allow us to spawn our instances. So now that we've basically covered all of this, let's go over to our main project and let's get started on that. Alright, so let's get started. The first thing I would like to work on is the pillars on the inside of the building. Now at this moment we have nothing on the inside of our building, and that's not particularly structurally sound. So let's go ahead and add those first. Now I am going to base these on the same interior grid that we are using for the elevators and the staircases, so we can get started with this quite quickly. So up here in our network, what I'm going to do is I'm going to drag a line from our remove inline points node. And if I just quickly look at that one, you can see that we do have a nice grid with points that will do perfectly for our pillars, right? Now you could upgrade this later if you want to with its own dedicated grid once we finish the vents. That's all up to you. But for now I'm going to keep it simple because I want to explain to you how we are going to keep these points away from the outside of the building. But okay, so let's go ahead and grab a line from this remove inline points node, and I'm just going to temporarily increase my screen to do so. And I'm going to pull a line and I'm going to create a null node right here on the right. And I'm doing this because I need to grab data from this node, but also from a couple of other nodes as well. So here we have the interior grid, but then next to that I will also need to grab from here from the isolate floor plane node. And this one covers the entire exterior of our building. This one comes right before we create the floors for our building. So let's grab a line from that and let's pull this over here to the right as well. Now, if you have too many lines crisscrossing one another, you could always use object merges, but those have a downside as well, because basically object merges have invisible lines, and if you have too many of them, then it might become hard to know where your data is going. In this case, I'm just going to pull a line because this is one of my main data sources, one of my main sets of data, and I will need to use it more here on the right as well. And then last, what I need to do is grab the shafts as well, because we also need to make sure our pillars stay away from those. So let's copy this object merge, and I'm going to pull this one over to the right as well. Okay, so now we have these 3 pieces of data. Next, let's go ahead and create a net box. And I am going to grab this one, and I'm going to put it somewhere down here, far enough away from the rest of my network, because we will actually need to go ahead and create the elevators and staircases later, and those will need a little bit of space. Alright, so down here, let's grab these nodes and let's pull them over. So just like before, we can grab them, then hold Alt, and this will create a dot, and then we can just move these around to create some proper lines so they don't intersect with anything. Let's do this for both. I'm just going to pull this data down here like so. And then later we can grab data from here for the instancing system as well. So inside this network, let's give these null nodes some names. So this one is the interior grid. And then the other null node is going to be my building profile. Now with those, we are completely set to go ahead and cull out some of these points so they don't intersect the outside of our structure. Let's grab our new delete by distance sub. So let's go ahead and plug this one up. The interior grid is our main input, so that's the one we are going to cut away from, right? And then the building profiles, the outside of our building here, is going to be put in the second input. Now this node at this moment is deleting based on points, right? So every point on this outside profile here is being detected, and the points of our grid are going to be deleted based on that. But if the outside this building were any less dense, like say if we reduced the amount of windows on the outside, this wouldn't be as dense, so this might not work as well. I can actually demonstrate that if I just create a facet node and remove all of the inline points, and you'll see what I mean. Now suddenly there's no more points on this mesh to detect, and this means that our delete by distance node can no longer properly work. I want to avoid this issue, and we already built the delete by distance node in such a way that we can. I'm simply going to set it to delete based on edges. Okay, so the type to detect is going to be primitive edges instead. You can't use primitives because it would detect the entire primitive, and we haven't turned this into a polyline. But like this, by detecting the edges, we are simply going to delete every single point that is too close to any of the outside edges here. And we can set the distance that we want our pillars to be in order to make sure they don't spawn too close. I'm going to set this to a default value of 1 because that is the minimum distance a player needs to navigate between the pillars and the outside. But I am going to actually add a little bit of extra here to make sure that we are accounting for the thickness of the pillars and the thickness of the walls. Let's first set up the rest of this system, and then we'll deal with the variables after that. So next, I need to make sure that I delete all of the points that are right on top of our elevators or our staircases. And for that, if I just look close enough, you can see that these elevators and staircases are not sitting on top of this grid. Now we can of course fix that if we grab another delete by distance node. Let's reconnect this one up. So our main grid goes into the main input and our elevator shafts here go into the second input. Now this one needs to delete based on primitives, right? Because instead of the edges, what I would like to do is grab the entire mesh, or at least the mesh surfaces of these objects. Let's switch it over to detect primitives instead. Now, if I go ahead and set this value low enough, at this moment, our points are going to be right below, but they won't be able to detect the mesh, right? So if I turn on pre-flatten, we will detect in 2D space, meaning height no longer matters, and then it will always work, no matter if these shafts are actually above or below. Again, as for the distance, we are going to set this one to a size of 1, so 1 meter distance. And then likewise, we'll hook up the rest of this in a minute. And just to make it clearer what these delete by distance nodes are doing, I'm just going to give them a couple of names. This one is going to be working based on primitives, and the top one is going to be based on edges. Now next, let's go ahead and copy a couple of pillars onto these points. I'm going to go over here on the left of my network and expose the floors right there. And at this moment, our grid is sitting a bit too low. It actually needs to be raised up by the floor depth, right? So let's grab a transform node. And I'm going to call this one raise on top of floor, right? Let's grab our parameter interface. And I just want to grab the floor depth over here. So over here in translate Y, let's paste that in. And that will deal with the basic offset. And then let's create a copy to points node. Put that one here. This is going to be the copy to points for our pillars. And then I want to create a basic pillar shape as well. Now at this point, I'm simply going to create a grid and extrude it up by the floor height minus the floor depth, right? So similar to what we did for our tiles, because I want to make this one sit right in between our layers here of our floors. Let's create a grid. This one's going to be my pillar template. And then let's create a poly extrude and plug that in as well. Now I am going to quickly plug everything together and then we'll configure it. So we need to make sure that our spawn points go into the second input of the copy to points node, and then our pillars are going to go into the first. Okay. Now it looks like by default we don't have the correct orientation, so I'd like to fix that first. Let's create a attribute wrangle over here. And we need to set up the normal direction and the up vector as well. So let's call this one set normals. And inside this node, I'm going to write a couple of attributes that we need in order to make our copying system work properly. So the first one is going to be our normal, which is the forward facing normal of this pillar. So I'm going to call this one v at n equals, and then if you want to define a vector, we simply need to type them inside curly brackets. So we can say curly bracket open and close, and then 1, 0, 0. So this will face in the x forward direction, right? If I do that, it should already align my grids properly, because now they're actually facing in the right orientation. But I still want to fix this so it never has any issues knowing what is the actual up direction of our grid. Because potentially they could still technically be rolled upside down. So for that, we can define an up vector. v at up, lowercase, equals 0, 1, 0. And with that, we now should have an up vector here, which is going to secure our orientation for our plane. Now last, I also want to make sure that we always have the correct point scale set. And for that, we can simply create a float attribute called pscale. And I'm going to set that to 1. So now that we have our normals and our scale secured, let's go over to our template over here and let's change its size as well. Now, I do want to actually create a new parameter for this. So let's go over to our type properties. And in here, I want to create a new folder in between our elevator and staircases and setup folder. Drag one over. And I'm going to call this one the props. So our props folder, right? And then in this folder, I'm going to drag a new float value. And let's call this one the pillar scale. I'm going to give it a range, a size range of 0.1, lock that 0.1, up to 5, though I don't think you should make your pillars too big. And then under channels, I'm going to give it a default value of 1. Let's go ahead and apply that. And I'm going to grab it from over here. And let's plug it into our pillar template. I'm going to plug it into both the X and Y values. So we have a uniform scale. And then let's also reduce the amount of rows and columns to 2 each. Now at this moment they're still too big, and the reason I want it to be a value of 1 is because this is going to be the default value for these pillars, but I do want them to be a bit smaller. So I'm simply going to multiply this by 0.5. So we can scale our pillars and make them double their size or half their size, but they will always have a default value of 1 to start with. So now that we have our size value, let's also plug it into our poly extrude. So we have that set up as well. Let's call this one the poly extrude for the pillars. And I'm going to give this one the height of our floor under its distance value. And then let's go ahead and reduce it by the floor depth. Right? So floor height minus floor depth. So now we should have pillars that are sitting nicely in between our floors, and they're not too big, and they're also avoiding our elevators as well. Now I do want to control this a little bit more, so let's also grab our current prop scale and let's add that to our distance threshold for the distance to the walls. So here we have the outside of our building. These pillars are probably too close to the walls, so let's account for their thickness and also the thickness of the walls themselves. Now, in order to make sure that we are actually getting the correct pillar thickness and not the normalized value here, let's grab it from our pillar template. So over here, let's go to our size X channel, copy that. These are uniform, so it doesn't matter which one we grab. And then inside of our delete distance by edges, let's grab the distance threshold. Let's add that to our value of 1. Okay, so that's already removing these points. And now just to be sure, I also want to make sure that we remove them if they're too close to walls or if our walls get too thick. So under building settings, let's also grab the wall thickness as well. And let's add that one as well. So just test, let's increase our wall thickness a bit, and you can see how the pillars will be removed if they get too close to our walls as they get thicker. Then next, let's deal with the second delete by distance node. Let's render that one. And in this case, I just want to make sure that if the pillars get too thick, they also stay away from these. So let's add our pillar thickness once more to this one as well. Okay, so with this, we should have our basic pillar setup done. Now all we really need to do at this point is copy them up onto the floors, give them a collision, and maybe give them a little bevel as well. Just add a little bit of extra detail, right? So let's do that quickly. Over here on the left, let's go ahead and copy our floors node. Paste that down here. Let's call this one copy pillars. And just because I don't actually want to, have pillars on my roof, let's remove that value of 1 over here. Okay, so now they're sitting nicely in between. Then let's go ahead and grab our bevel and clean setup here from our top trim. Copy this entire network. Plug that in as well. And I think I want to color my pillars a bit darker than the rest. So I'm just going to make this, say, 0.25. Something like that. Our bevel settings and our triangulate are fine, so we can keep that. And then let's go ahead and plug this in to the end of our network. Now at this moment we have our pillars inside the building, but we still need to deal with their collision. Like if I look over here under my collision mesh, we don't have them here yet. So let's also bring them in here. Let's grab one of our collision null nodes that we have somewhere, like this one. And if I copy this, and assuming you haven't changed the numbering yourself, it should just give you a new number that continues from the last one. So this was the last one we added. The next one will be number 4. Let's grab that. Plug it over here. Under our copy pillars node, because we don't want to grab the bevels, right? Keep our collision mesh relatively low resolution. And then under in collision, let's just add a new entry here. Okay, so with that, we should now have pillars inside of our building. And before we continue, let's just bring this into Unreal and test it out. Save it out. Let's go to the Unreal Engine. And I'm just going to reload the tool. Okay, then I can click play, and let's try and see if we have some pillars in here. Yes, we do. And they also have collision. So nice. So that's the first element. And this will highlight how the delete by distance node is going to help us, and also how we can basically copy some elements around in our building. Because at this point, we've only really dealt with the outside tiles and our copying system. And we will need it for some more advanced parts right here, right? So inside of our network, what we just did is we set up our normals to make sure that our pillars are always going to be facing in the right directions. Because without this, they would be pointing flat onto the floor, and I don't want that. And yeah, from there, let's go ahead and create the actual vent distribution system for our rooftop next. Okay, so let's get started on that. Let's move over here to the right and create a new net box. I'm gonna make this one nice and large because we do need enough space for this. And then up top, let's call this one the vent spawn points. And I noticed I hadn't actually named this part yet either, so let's call this one the support pillars. Okay, just to keep it nicely labeled. Next, what I need is to grab the building profile, because that's going to be the main basis for where our events can exist. So let's grab that one. And I'm going to copy it and paste it over here on the right. And this should already have it hooked up, so that's fine. Plus, I will also need our elevator shafts. Now, I could pull a line from this and just drag it over like that. But I don't really want to cross-pollinate here, so let's grab this object merge and let's just duplicate it over. So we have a nice separate network here. Okay, so at this point, we have our input data. Next, let's go ahead and decide what we want to do with this. Because in this case, I don't want to use the already existing interior grid. I actually want to create a new grid altogether. And there are a couple of different ways how we can go about doing that. Okay, so the first method that I want to show you is the scatter node. Let's go ahead and create one of those. And the scatter SOP in Houdini will allow us to create a series of random points on a surface, or potentially inside of a 3D volume like a VDB volume, and we can have a range of controls on where these points are spawned. Now by default it will create an even distribution at a certain amount of points. So right now it's spawning, let's say 500 points, right? Now these points at the moment are being relaxed, and this basically means that as we increase the relaxation value, they can distribute it more evenly across the surface. But this does slow down the node, especially if you put it on higher numbers, so be careful with that. But if we turn this off, on the other hand, then you can see that they get a very random distribution, and this can be anywhere in the surface. We do have some control over where these points can go, so you could use various attributes over here, or maybe per primitive you can spawn a certain amount of points, and you can even spawn them based on texture space. I'm not going to go into this right now, but we will explore this in the next module of the masterclass when we're dealing with more random spawning systems. For now though, what I'm interested in here is to just create a series of relaxed points, and then I want to use a fuse node to make sure that they're all spaced a certain distance from one another away. So if we grab a fuse node here, and I increase the snap distance far enough, and you can see that we can actually control by how far these points need to be away from one another at the very least. So we can control a minimum distance for these points this way. Now next to that, of course, we need to make sure that they don't spawn too close to the borders or the elevator shafts. So let's go over here and let's grab these two nodes. I'm just going to do this temporarily, so I'm going to delete this in a moment. But what I would like to do is plug my spawn points into the points I want to cull, then plug the second input into my building profile again, and this will make sure our spawn points get removed if they get too close to the edges of our building. And then next to that we can grab the second Aliba distance and plug that into our elevator shafts again. So this is one way how we could make sure that we keep objects away from these and we still have a nice random distribution of objects. But that's the main issue here. These points are random. If I grab my scatter node and I change my global seed value, you can see that they are basically completely randomized and they can be anywhere inside of our building. We also don't have a proper control over how many points we will actually get. So I want to build a more robust system to deal with that instead. And I also would like my vents to sit on a somewhat controllable grid, right? Basically this grid over here. Now let's have a look at the second method that I would like to show you. I'm just going to grab these and get rid of them. I don't need them here, and they will be in the example files if you're interested. Then next, let's create a divide node. Now the divide node has the ability to not just basically divide our geometry, but it can also bricker it, meaning that if I turn off my convex polygons over here, and I just make sure I show my points, down below I can turn on bricker polygons. And this will, well, basically dice up our shape into grids, right? Like we can see here. However, I have noticed this node has some issues when it comes to properly evenly dividing our space. So while I can go over here to my size value and change this value around, it will work, and in some cases it won't. Like in this case, I think this particular cut here coincides directly with this edge, and as a result this cut fails. Now we might be able to clean this up a little bit if we remove the extra edges on our shape. So let's grab a facet node and try to clean this one up. Let's remove our inline points. And then let's look at the divide. And while it does work a little bit better, it still has some issues. Like over here, it seems to have an extra polygon right there. I don't like the behavior of this node. It's also a little bit slow. I mean, you can see that if I try to change this, it does chug a little bit depending on how many pieces I have. Now, this doesn't pose a massive problem for us, but I do want to make a robust system here. So let's delete these nodes once again. And the last method, and the one we're actually going to use, is the one we already built. Okay, so yeah, all that suspense, just say we're going to do what we did before. But I'm going to show you how we can take what we did before and make it easily copyable and modular, so we can just repeat it without actually having to turn it into a digital asset. Okay, now the nodes that I want to grab are the ones over here, this part of the network. This includes the flatten node, the interior grid base, the snapping system, the Boolean node that cuts our grid into our shape, and then the cleaning and culling system down below here for the cut pieces of our grid. Let's copy this. And now that we have this, let's go ahead and paste it over here inside of our new network. Then let's grab that and let's plug it into our building profile over here. And that should already give us something. But I want to make this controllable, because at this moment everything's still linked up to the top of our interface. And I don't want that, of course, because I do want to have this be separately controllable for our props. So let's grab this part of the network and let's wrap it into a new subnet. And I'm going to call this subnet the subnetwork grid spacing L. And the reason I'm calling this L is because I also want to copy this later for these small vents. This is for the large vents, and then we're going to copy it once we finished adjusting this one for the small vents. So for this subnet, what I want to do is grab its controls that are currently linked to our interface and instead link them to the interface of the subnet instead. Okay, so let's grab the parameter interface of this node. Not the type properties, but the parameter interface. And I'm just going to drag it over here. And the first thing I'll do is remove these labels. Let's make those invisible. All right. Then next, I want to grab a value called grid spacing, which is going to be the equivalent of what we had over here for our interior grid spacing, right? Because if I change this value, that's what's being adjusted. So let's grab a float, call that grid spacing. Now, as for its default values, I don't really care too much because this is basically a in-between parameter, and I don't want to lock this parameter, because if I do, and I hook it up to a top level, then for example, if it's set to locked to 1, then the top level can't make this value go any lower, even if I later want to change that. So any in-between parameters, like the one we're creating here, I generally leave unlocked, and at most I go ahead and set a default value, which in this case we can do, maybe set it to 1, but don't touch the range controls right here. I suggest you don't. Then with that, we should now have a grid spacing parameter right here that we can control. And let's also create a grid offset as well. We won't be using it, but it's still good to include it. So let's grab a float vector 2, set this one up, called grid offset. And once again, I'm going to leave all these values alone, and let's accept. Okay, so now we have a basic grid spacing control and our grid offset. Let's open up a parameter panel for this node so I can grab from it. So that's a separate parameter panel for this subnet. And then let's dive inside and set this one up. So for this node, the first thing that I want to do is set up a couple of basic housekeeping things, such as the input and the output. Let's create a null node. And I'll call this one the surface to grid input. Our flatten node is in the right place, so that's fine. Let's move this over a bit, move this to the left, this to the right, so we don't have any crossing wires here. This stuff can go away. And then let's create an output node at the end. Okay, so with that we now have our basic setup. Now let's see what we need to rewire to our interface, right? So the first part here is going to be our interior grid base. Now the interior grid base is still linked to our top interface at this moment. If I look at any of these, you can see it's still linking up 3 levels all the way to the top of our node. Let's replace this one with our new grid spacing here. Copy that, select this. Let's paste that in, and that should link that up. And let's do the same thing for the Z channel as well. Okay, that should be fine. And then next, let's grab our snap interior grid node, and let's replace all these values in here. So our interior grid scale becomes grid spacing. I'm just going to copy that, and then I can just paste it around. So over here we also have our grid offset as well. So we need to replace this one. In this case, just copy this one, replace its reference, and then for this one, make sure it's set to Y. Okay, so those are set up. We should now have control over these. Yes, that works. And we have control over this. Okay. Now at this moment our grids disappeared, and that's because our culling system down below here also needs to be updated. So for our isolate clean squares, let's take our grid scale here, and let's plug that in as well. Okay, so with that we now have a controllable system, and because our code is still working, as long as we don't go below a size of 1, which is based on the rows and columns here, our snapping system should work and we won't have any problems with that. So let's set this over to a default grid spacing of 3, and then let's go outside of our node, and with that we now have a proper grid spacing node ready. So if you want, you can actually copy this and put it over here in case you want to use a dedicated grid inside your building. But for now, let's go ahead and grab this and let's start building out our little system. So this node is going to need to be culled, just like our network here. So let's grab these nodes and let's plug these in again. By default, we have our building profile over here. Then we have our grid spacing. Let's plug it in like so. And then next, we need to plug this into our elevator shafts as well. Okay, so this should now give us a proper grid that we can control. we can control the size and distribution, and we can control the offset as well if we want to. Now as for the values on these nodes, I do want to change this. At the moment, our distance threshold isn't controlled by our vent spacing, it's controlled by our pillar scale. So in order to fix that, I want to create a dedicated node that is going to store all the distances and the sizes of our vents. So we have a centralized control point to change this information on. Up here, let's create a new null node for that. And I'm going to call this one the vent spacing null. Let's give this a blue color because it's an important value node. It contains important parameters or attributes that we are referencing from somewhere. And then let's go ahead and open this one up as well, its own parameter interface. And let's add the parameters that we need here. So I'm going to hide the current default parameters on the null node. So we have a clean null node. And over here, I want to add a couple of new parameters. Now, the first parameter that I want to add, or the first few, are for the vent sizes. Let's add two floats in here. And the first one I'm going to call vent size underscore s for the small vents. I'm going to lock this one at 0, so we can't get any negative values. And then under channels, I'm going to set this one to a size of 2, because the vents that we have on our roof, at least the small ones, are about 2 meters wide in size. Okay? And then the big ones are about 4 meters, at least in their length. So let's go back and let's do that one as well. Vent size L, locked at 0, and its default value is 4. Okay, next, let's go ahead and add a separator. And then I want to add some controls for our vent spacing. So I'm going to create a float. Let's call this vent spacing. And again, I'm going to lock its minimum value at 0, so we can't go negative. And then let's copy this one twice. And I'm going to call the top one vent spacing S. And the bottom one vent spacing L. And the reason I'm separating these is so I have a centralized control for my spacing, and then a dedicated set of parameters that I can put expressions in order to scale each one independently. So I'll show you what I mean. So let's close that. And then just to explain to you what I'm going to do for these vents and what I'm going to set up here, let's go over to the drawing board. And I want to quickly show you what I'm planning to do here. So let's say I have my grid inside of my building shape here. Then we're going to spawn a couple of vents onto that grid. From there, they will have a radius based on their own size to prevent other objects of their own type from spawning anywhere nearby. So an object that's 3 meters in size will have a radius of 3 meters, preventing objects from spawning next to it, like down here, for example. Like this point here, these points are going to be invalid. Now in this case, we are using the center point of these objects. We're not actually measuring the outside of our mesh. We're not copying our mesh onto our points and then measuring if the object might be close to the border of the mesh. We are checking the center of the mesh. This is not as accurate as checking the outside of the mesh, but it is definitely faster. Okay, and that's what I'm going with here. In this case, these objects are simple enough that I don't have to worry about this. Now in this case, if the object down below here is inside of the range of the object above, then it won't be allowed to be placed. That's basically the simple rule here. So over here, what I want to do is define the minimum spacing for each type of vent based on a base control and then the size of these vents. So let's set that up. The basic vent spacing is going to be a parameter I can control from my interface. So let's grab the type properties. And I want to hook that up. So down here in my prop section, let me grab my vent spacing control and let's plug that in. I'm going to put a separator between those two. And as for its values, we've already set this up. I think I'm going to just make sure that the default value is going to be 1. Because by default, I want to have my vents spaced 1 meter apart from one another. Additionally, besides their actual size, so the player will always be able to walk between them, right? We need 1 meter space. Let's apply this. And then, inside of our vent spacing node, let's set up the little equation we need for both our vent sizes. Let's copy the vent spacing over here and paste it into both of these. So that's our first value. Then I'm just going to grab the vent size S and add those to the small vents. Copy the vent size L, do the same. Now our vent spacing is going to make sure that we can add additional spacing to our vents. So we never create a completely enclosed space for the player. In general, that's the idea. Now at this point, I'm basically just giving you a couple of arbitrary values, and this might be a bit hard to follow. So just to make this visually a bit clearer on what I'm doing, let's create a little dummy setup so we can at least see what we're doing. Let's create a copy to points node. And then I'm going to create a file node as well. And this copy to points node is going to simply load one of our models that we can then temporarily anyway copy onto these points. Let's go in here, go to our job folder. From there, under Geo, we can navigate to the Roof Deco HVAC Large. If we grab this one, we accept this, then this is going to copy one very big HVAC unit onto our point. In this case, it's way too large and we need to fix this. So I'm going to grab from here on my left my set normals node, plug that in, and I am also going to temporarily scale it down to 0.01. This should make it at least accurate to what we're doing. Now at this point we can still see the collision mesh that's part of this FBX file here. I want to get rid of that, so let's grab a blast node. And what we can do is we can actually address an attribute that is present on our mesh. If we look under the primitives tab and we scroll to the right, we can find the name of this particular part of the mesh. And what I'm looking for is the UCX HVAC small 01. This is the collision box that's part of this mesh. So if I filter for UCX, then I can grab those and I can delete those. On the blast node, let's filter out for primitives, and then let's type into the group field at for attribute name equals UCX asterisk. And what that will do is it will basically filter out every single attribute that starts with UCX, the asterisk here being a wildcard, meaning that anything that comes after UCX will be valid, no matter what it is. And then it's going to select those and delete those. That's pretty simple. So here we now have a representation of each of these objects being spawned, and we can see that they are overlapping to some extent. So we need to control our distance values here. Let's go ahead and set this up. So right now we have our vent spacing. We need to increase this to the point where the vents are so far apart that they will never intersect anymore, right? And we already know what our vent spacing is. Over here, under vent spacing, we can grab the vent spacing large, copy that, and then under the grid spacing here, plug that in. And now you can see that the vents are about 1 meter apart in between, and they're working properly. Okay, that's the first part. But it doesn't actually take care of the spacing between this and, say, the border of our building, right? So if I grab my grid offset, you can see that they can still get too close and block the border of the building. So let's go ahead and fix that next. Over here, under my delete by distance, the edges, which is currently hooked up for my pillar template size, let's switch this one around. So to change this around, let's grab the vent spacing large value from our vent spacing node, copy that. And in fact, I'm just going to pull out the parameter panel for this one again, so I have it over here. So let's go ahead and plug this in, just replace this entire value. But this will now remove any vent that is at least 3 units away from an edge. So that's an entire vent size. I don't need that much space. So then let's grab the vent size over here, copy that, and I'm going to subtract half of this from the distance. So we can just say our vent spacing minus the vent size times 0.5. And because of the math priority, this will always be multiplied first, and then we subtract that from this. Now I'm going to quickly interject here and tell you that during the editing process I corrected a mistake. Originally I had recorded my vent size as 1 and 3 meters, and this should be 2 and 4, because that's more accurate to the actual model size. But this will mean that in some cases you're going to see some of my vent spacing numbers be slightly different than what you might be getting with the 2 and 4 values. Don't worry about this though, it's not a big deal, but just something to be aware of. Now let's continue on with the video. At this point, if I now grab my grid spacing and I move it around, it should keep our vents nicely away from the edges, so that's good. Okay. Then next, let's do the same thing for our elevator shafts. I'm just going to copy this expression, plug that one in there, and now depending on where our elevator shafts are, it will keep them away from those as well, and it should no longer be able to ever block the player, which is important because we need to be able to leave these things, right? We don't want a vent spawning right in front of a door. Okay, so with that we now have the first setup here done. And I'm just going to add these to a couple of net boxes to keep it a bit cleaner. So I'm going to grab my vent spacing, wrap that inside of its own net box. Call this one vent controls. And then this part here is a temporary setup. I'm going to wrap this inside of a network. And this is a bit of a preview for me, so let's call this one mesh preview. Okay. So with that, I'm going to copy this entire top section, including my netbox. Copy it and paste it to the right. So this part here on the left is for my large vents. Then this part on the right is going to be for my small vents. Okay. Now let's rename this one and let's change its values in these nodes so they reference the small vent distances instead. Change this one to the S value. Then in here, let's do this one too. And then let's paste that one down below as well. Okay. Now as you can see, our visuals are getting too big, so let's replace that one as well. Over here for our mesh, let me browse and select the small vent instead. And that should give us a proper idea on the size of our small vents. So now this is working as well. Okay, cool. So at this point, we now have our basic grid spawning system done. Now, before I continue, I just quickly want to show you something about the file nodes. They have the default behavior to report an error if they ever find a missing file. So if your job path, in this case, isn't actually set up properly, or if the file itself doesn't exist, then the node will throw an error. And when that happens, of course, if it's hooked into your tool will break. So you don't want that. In this case, the best thing to do if you use a file node is to always just set it to no geometry instead. And then it will just skip that geometry. Okay, so unless you absolutely need a file to be loaded, I suggest you turn that off. So let's set this up for both of these, just in case. And then next, what I would like to do is go ahead and build the next part, which involves the filtering of our points based on a ratio, so we can balance the large and small vents against one another. Now, at this point, we have already 1 hour of video behind us, and I think that it's best if I split the video here and continue in the next one. I said this would be one video, but it's gonna take too long. So I hope to see you in that next video, and have a good one.